Hi, good morning, or good evening, or good afternoon, whenever. Angles of elevation and angles of depression. If you are going to study angle of elevation and angle of depression, you must study or know the right angle, the triangle. Firstly, if you are standing on the floor and start to observe a building or a tree or a lighthouse, whatever, at the top of the building, and from this point start to look at the building, and now you can look from the horizontal to the building, and look there, look up to the top of the building. This is our building. This is the building. Now you have something here, or angle here is called theta. Theta here is angle of elevation, the angle we look up, the angle which we look up. And we look to it with the horizontal. Angle of elevation means the angle with horizontal. This is angle of elevation. And sometimes you are upstairs or up and start to look from up. So this is angle of elevation. And if you are standing at the top of the building and look at something on the floor, just like that, this is your eyes, or this is the place you can stop at here and start to look down at something down. So with the horizontal you have an angle. Theta here is called angle of depression. Angle of depression. Angle of depression and the angle of elevation are the same, because here the horizontal is parallel to the horizontal. So they are going to be alternate angles. So theta here must be equal to theta here. Okay, let's deal with problems to know more about angles of elevation and depression. First, you must know that drawing is the most important part. How to translate the words, the given problem, into a drawing. From a point 8 meters apart from the base of a tree. From a point 8 meters apart from the base of a tree. So, firstly, we have a tree. And you know that the tree is perpendicular to the floor, and this must be your floor. And you have a point here, and the point is 8 meters from the base of the tree. He said that. Find the measure of elevation angle. He knows that you are going to look from here to look upstairs or look at the top of the tree, and find that if you look here, you will find that angle of elevation is 22 degrees. Stop here and look. So this angle is going to be 22 degrees. What do we have? Find the height of the tree. So he asked you to find here the height of the tree, which is called x, for example. Okay. What do we have? We have a right angle. And an angle in the right angle of the triangle, and we need the opposite, and we have the adjacent to the angle. So what can we deal with? We are going to deal with tan. The angle tan 22 is going to be x over 8. So firstly, we must talk about how can we convert the words into drawing. apart from a point 8 meters apart from the base of a tree. It was found that the measure of elevation angle, you know the elevation is the down angle, and you know that the elevation for all times equal the angle of depression, so it's 22, the same up or down, whatever, not up here, it's up the horizontal. Okay, and this is the height of the tree, and we have this place. What do we have here? We have a right angle, the triangle. How can I get the x? You have x and you have the angle and you have 8. What is the relation between x and 8? Opposite, and the angle opposite, and the adjacent and the angle. So we have tan 22 equal x over 8. Then x, or the height of the tree, is going to be 8 tan 22. And he asked to approximate the result into, you are going to put it in the calculator. You will find it's a 3.23 meters. He is asking about approximating to the nearest to 2 decimal places or hundredth. You will find it's 2.23. Next question. You have airplane 1000 meters high was observed by a person. Your train was on height 1000 meter, observed by a person at angle of elevation 25 degrees and 17 minutes. The distance between the plane and the observer. Let's draw. To say again, the drawing is the most important part in this type of questions. You have a plane, yeah, and our plane at height 1000 meters. So the plane at height 1000 meters, and someone look at it from this place, for example, with angle of elevation 25 degrees. So here the height is 1000 meter, and the angle here 25 degrees and 17 minutes. Find the distance between the plane and the observer. This is our plane and this is the observer. So he asked to find x here. So we put x here. Take care of the words. He asked to find the distance between the plane and the observer. This is the one who was observed, and this is the plane. So we have opposite and hypotenuse and angle. So opposite and hypotenuse is going to be sine x. It's going to be sine x. Sine the angle, sorry. So it's a sine 25 degrees and 17 minutes will be 1000 over x. In this case, we wanted to get x. You can just put 1 here and make crisscross to get x easier. X will be 1 times 1000 means 1000 over sine 25 degrees and 17 minutes. Don't forget to close the bracket if you put it on the calculator, because if you didn't close the bracket of the denominator, you will find it's wrong. You will get it wrong. So it's going to be 2341. It's going to be approximately 2341 meters. Sometimes you find it's to the nearest. He's going to tell you to the nearest what. From the top of a lighthouse 200 meters high. So we have a lighthouse 200 meters high. We have a lighthouse 200 meters high. Let's draw. This is our lighthouse. Forever we have a right angle triangle. This year, next year you might have something else, but here we must have right angle triangle. And start to draw your lighthouse. Your lighthouse, it's 200 meters. The lighthouse 200 meters high. Was found the measure of depression angle of about 31 degrees and 14 minutes. So if he stop at the top of the lighthouse and start to look down, you found that the angle of depression of a boat is 31 and 14. This angle, this is our theta, which is 31, 14. Also, that means that this angle is going to be also 31, 14, because the angle must be in our triangle, inside the triangle. And the height of the lighthouse is 200 meters. Find the distance between the boat, this is the boat, and the base of the lighthouse. So he asked to find this part. Okay, so we have the angle and the opposite, and asked to find the adjacent. So we deal with tan theta, tan 31, 14 equals opposite, which is 200, over adjacent, which is x. We put here 1 and start to make our crisscross. Then x will be 1 times 200, which is 200 over tan theta, which is 31, 14. It's going to be 329.8 meters, equal 329.8 meters. Next question. Find the measure of angle of elevation of the sun when the shadow of a flagpole of height 3.2 meters is 2 meters. Another time, find the measure of the angle of elevation. Find the measure of angle of elevation of the sun when the shadow of a flagpole of height 3.5 is 2 meters. You have a flagpole. Flag, you know the flag when we say Mr. Arabi. It's our flagpole, and it has a shadow. The shadow will be on the floor at 2 meters, distance 2 meters. This is the shadow, and this is your flag. It's 3.5. He's asking about angle of elevation of the sun, because the sun, which makes our flag. So he asked about theta here. He's asking about theta. So we have tan theta. So here we have the opposite and the adjacent. So we have tan theta. Tan theta here. Tan theta is going to be 3.5 over 2. You make shift tan 3.5 over 2. You have 60 degrees and 15 minutes angle. This is your elevation angle. So next question. Upper end of a ladder rests on a vertical wall. It's 3.8 meters far from the surface of the ground. Of course, you know that the ladder, if the ladder stopped at the wall, it will make this shape. You mean this is the wall, and this is the ground, and this will be the ladder, right? Complete. It's on the upper ladder, vertical wall, 3 meter from the surface of the ground. So here 3.5 meters. .8 meters. The lower and rests on horizontal ground. The measure of the angle of inclination, elevation of the ladder 64, in the ground 64. So this is 64 degrees. This angle is 64. He's asking to find the two things. First of all, distance between the lower end and the wall. So this part, X. Here, this part. And also the length of the ladder, say Y, okay? First of all, we start finding the relation between here and here. It's going to be tan. So, tan 64 is going to be 3.8 over X. Also, we make crisscross, and X will be 3.8 over tan 64, which is 1.85 meters. And here we have opposite and hypotenuse, so we take sine 64. It's going to be 3.8 over y. Same way, you find that y is going 3.8 divided sine 64. It's going to be 4.23 meters. 23 y will be 4.23 meters. From the top, from the roof of a house 8 meters high, a person found that elevation angle of a top of opposite building was measured 63 degrees and observed the depression angle of the base. It was measured 28. Find the height of a building to the nearest meter. We have two perpendicular here. We have the house and the tree, the building. So this, if this is the building and the building is higher, this is the building and this is the floor. This is the floor and this is the building and this is the house, right? So from the base, from the top of the building, from the roof of the house, and the house is 8 meters high, a person found the elevation angle of the top of the building was 63. He look here, look at the top here, and found that the elevation angle here with the horizontal, of course, is 63. This is the 63. And observe the depression angle, also the depression angle of the building, from the same place on the roof of the house. He found that the depression angle of the base of the building is 28. Find the height of the building to the nearest meter. Another time. This is the 63, the angle of elevation. This is the 63 angle of the elevation. And this is the angle of depression, which is 28, right? And this is the house, which is 8 meters. First of all, this equal to this, so this is going to be also 28 alternate, and this is 8, and this is going to be also 8. Okay? Now he asked to find the height of the building. First of all, I'm going to find x, which is here, this part, because it's equal to this part. So here x and here x. So we have opposite and adjacent. It's tan 28. It's going to be 8 over x. From here, x will be 8 over tan 28, approximately 15. So this side is going to be 15. In this triangle, ask to find y. He's asked now, time to get y. We have the angle, and we need the opposite, and have adjacent, and we have the angle. So tan 63 will be y over 15. So here y will be 63 tan 63, sorry, tan 63 times 15, which is going to be approximately 29 meters. Now this part is 29 and this is 8. If you wanted to find the length of the height or the height of the building, it's going to be 29 plus 8, which is going to be 37 meters height. Thank you for listening. See you soon. Thanks. Senior 1.